Welcome to You Got Hope Science. I'm Hope, and you're about to learn some science. In today's lesson, we are going to look at doing some algebra, or in other terms, we're going to look at rearranging equations to solve for a certain variable, which is a huge part of physics and mathematics. And so we're going to start with some easy ones. We'll work our way to ones a little bit harder to give you a good idea of what you're to kind of expect as you move forward in physics. And a lot of these things that we're going to do will apply to the equations we use in physics this year. So the first thing I want to say is whenever you want to isolate a certain variable, you essentially always want to do the opposite mathematical operation to move it from one side of the equation to the other. And another thing that helps is doing this in the order of BEDMAS backwards, or SAMDEB. So rather than starting with brackets, etc., working towards subtraction, we usually start with subtraction and addition, and we work back the other way. It's not a perfect thing to say using BEDMAS backwards, but a lot of the times it actually does help. So let me first explain to you what doing the opposite operation means on a couple of simple questions. So I have a number of things we're going to rearrange here. We're going to rearrange and solve for all of the letters that are circled in red. And so if I started up here, and I wanted to isolate b on one side of the equation, that means I have to move the a to the other side. Now it's being added to b, so the opposite thing of adding would be subtracting. So what I would do is I would subtract a from this side, and whatever you do to one side of the equation, you have to do to the other. So that means I would have to subtract a away from this side. That would cancel this a out. So b would equal c minus a in order to solve for b. Now, just to make sure that you are have some context of what's going on, I'm going to use some real numbers to kind of like help prove that what I did was correct. I'm not going to do it for all of the questions, but just maybe a few of them. So for instance, let's say we had 2 plus 3 is equal to 5. Okay. What we did is we subtracted across the first number, the 2, to the other side in order to solve for what essentially would be 3 here. So if I subtracted 2 from here, and then I got to subtract 2 from the other side, and I'd be left with the equation of 3 is equal to 5 minus 2. Now that's true. I know 5 is equal to 5 minus 2, which means that this is true too. Whatever these values are, it's going to equate the exact same thing of whatever's on the left-hand side of the equation, equal sign, to whatever's on the right of the equal sign. So remember, if you wanted to, you could put in values in before and after and see if it actually works out. All right, so if I go to the other side here and I'm solving for a, the opposite operation of subtracting b would be to add b. So I'm going to add b here, and I'm going to add b here. Whatever you do to one side of the equation, you have to do the exact same thing to the other side. So this would get rid of b, and so my answer would be a is equal to c plus b. That's my rearranged equation for a. All right, let's do a little bit of multiplying and dividing. So right now, a is being multiplied by b, and I'm trying to get a by itself. The opposite of multiplying is dividing, and whatever I do to one side of the equation, I have to do to the other. So I would divide this side by b, and then I'm going to divide this side by b, and that will cancel that out. So a would be equal to c divided by b. So let's just put in some numbers and see if this can make some logical sense for you. So what times what? Let's do something like 2 times 5 is equal to 10. Now, I'm just going to do the same thing as I did above. So let's say I divided 5 across That would cancel that 5 out. And if I divided this by 5, I would get 2 is equal to 10 over 5, which is true. If I go 10 divided by 5, that's 2. 2 is equal to 2. And this proves that my rearranging I did above is correct. So if I go beside here, similar thing. If I want to isolate b, that means I have to move a to the other side. So I'm going to divide both sides by a. That will cancel out the a. And so now I know b is equal to c divided by a. These equations here, this rearranging we've done here and here, are things that we are going to be doing with in physics, okay? Same with the next two. The next two are something we do a lot of in Science 10 physics. So let's say I wanted to isolate A, but it's being divided by B. Okay, the opposite operation of dividing is multiplying. So if I multiplied both sides by B, that would cancel out the B here. And so A is going to be equal to C times B. And then here, this is a little bit different and a little bit more tricky to work with. So let's say I had B and I want to isolate B, but it's on the denominator of a fraction. I really would like to have B on the numerator or the top of this equation. So there's two ways of doing this. I could, no matter which way I do it, it's going to take 2 steps to work, okay? So what I'm going to do is I'm going to do probably the most common way of rearranging this. The first thing I'm going to do is I'm going to get B off the denominator. I'm going to bring it up to the other side in order to get it on the numerator. So it's being divided. The opposite is multiplying. So I can multiply B up to the other side. And then what I end up with is A is equal to C times B. Now I still have to isolate B, but at least it's on the numerator now. So in a second step, what I could do is move C to the other side by division. So I could divide this side by C and this side by C, and we would be left with B is equal to A over C, which is correct. Now, another option for doing this, I'm going to do it up here where I have a little bit more space. I'm going to start with my original equation, which is A over B is equal to C. Now, a lot of people don't understand when you have a variable and it's not over anything, it's really over 1. This is really C over 1. Now, what I can do to get B on the numerator is I can invert that equation by taking it to the power of -1. Now, a lot of students haven't seen this before, but if you take a fraction and you take it to the power of -1, what it does is it turns it upside down. The numerator becomes the denominator and the denominator becomes a numerator. But if I do that to one side, I have to do it to the other. I would have to take this to the power of -1. So what you'd end up with is B over A is equal to 1 over C. Now, that gets my B on top, but I need to get my A to the other side, so I still have to multiply both sides by A in order to get A on top. And so it would end up giving me B is equal to 1 times A, which is just A, all over C, which is the exact same answer, but it's in a different way of doing it. Like I said before, I think most students prefer just to move the denominator up like this and then move the second piece across. Some students really do like taking the inverse of both sides and doing it this way. Mathematically, they're both correct, and so it really doesn't matter which way you do it. So let's move on to the next couple. Here I've actually included a number, the number 2. So all I need to do is to move the 2 over to the other side is division, because the opposite of multiplying, 2 times A, is divide. So I'm going to divide this by 2, and I'm going to divide that by 2. That will cancel this out, and so A is equal to B over 2. So now we have an equation that has a number in it rather than just all variables. This one here, we will see this when we get to kinetic energy in a form of this, where EK is equal to 1/2 mv squared. And so if I want to isolate something and it's being multiplied by a half, you can look at it in a couple of different ways, but it's really the exact same thing, which is if I multiply this by 2 over 1, then I can multiply this side by 2 over 1, and of course the 2's on top cancel, the 1's on the bottom cancel like that, and so I'll be left with a is equal to 2b. Now the other thing I could technically do, but it's usually not kind of done because we'd be dividing a fraction, is if I wanted to, I could divide both sides by 1/2, because that's going to be b over 1/2, which is the same as 2 times b. But this would be the better of the two answers. So I do want to clarify that there is two ways of answering this, but this would be the best. The other option is going a is equal to b over 1/2, except b over 1/2 is 2b. This is a better way of showing that work. Okay. All right. The next one, I have a value which is squared. And we're going to have this when we do kinetic energy. We're going to have v squared, and we're going to have to isolate it. So a lot of people don't know, but the opposite operation of squaring is square rooting. So to get rid of this 2, the squared, I have to square root both sides of the equation. So I'd have to square root this, but I'd also have to square root all of this as one thing. So this would be a is equal to the square root of b minus c. Okay. Now, if I wanted to go the opposite direction and I have something which is square rooted and I wanted to get rid of the square rooting, then I'd have to square the other side. So if I squared this and I squared this, I would end up having the same thing, so b minus c squared. Okay. Just a couple more to do. This one looks like we're going to have to do some kind of squaring or square rooting because of the squared, but we don't. We simply just have to isolate the c. Now, there's a couple of ways of doing it, but I don't like this negative here. What I would like to do is I'd like to make the c positive. So I'm going to do a two-step rearranging in order to do that. What I'm going to do is move c over by the opposite operation of subtraction, which of course is addition. I'm going to add c to both sides. That'll get rid of the c. And I'd have c plus a squared is equal to b. But now I have to move the a squared to the other side. So I'm going to do that just by subtraction. The opposite operation of addition is subtraction. So I'm going to subtract a squared from both sides. And I'm going to end up with c is equal to b minus a squared. All right, the same thing over here. I have a square root, and you think, oh, I got to do something with this square root, but I don't. I want to isolate b, so I simply have to move c to the other side. Because it's being subtracted, I'm going to add it across to the other side like this. And so b would simply be equal to the square root of a plus c. For the rest of this lesson, we're just going to look at doing some simple rearranging and with some calculations. So for instance, this would be a circumstance where we have two variables, for instance, in an equation that we have a value for, and so we've substituted in those numbers. And now we actually want to solve for a variable. And in this case, I'm just going to stick with the variable x throughout all of the questions. And we're just going to slowly build up the difficulty level. Not that any of these are too over the top. So let's look at the first one. I want to isolate x. So I need to move that 5 to the other side. The opposite operation of adding is subtracting. So I would subtract 5 from both sides. And so x is going to be equal to 12 minus 5, which of course is going to be 7. Now, if I want to double check my work, I can simply put 7 in there, go 5 plus 7, and that is equal to 12, and so I know I've got it right. Let's try the next one. I have x minus 6 is equal to 9. Well, I want to move this 6 to the other side, and the opposite operation of subtraction is addition, so I would add 6 to the other side. So 9 plus 6 is 15, so x is going to be equal to 15. Now, if I want to check it, I could substitute 15 into this spot and go 15 minus 6, and I would get 9, and I know I've done it right. Carrying on, I have 8 minus x is equal to 5. Now, I kind of want to make the x positive. I don't like it as a negative value. So what I'm going to do is a two-step process here. I'm going to move the x to the other side by addition to make it positive first. So for instance, I'm going to add x here. I'm going to add x here. That would cancel that out. So I get 8 is equal to 5 plus x. And then I'm going to subtract the 5 to the other side. And 8 minus 5, of course, is 3. So x is equal to 3. And then I could double check my work. If I put a 3 into there, 8 minus 3 is equal to 5. So I know I've done it right. Let's move on from adding and subtracting and do some multiplication and division. So if I had 4x is equal to 24, and I wanted to isolate x, I would do the opposite operation, which is division. So 4 times x, I would actually go 4 divided by x, and I go 24 divided by 4. So x is equal to 6. Now if I want to double check my work, I just go 4 times 6, and sure enough it comes out to 24, and I know I've done it right. Let's try another one. So something over 10 is equal to 4. I want to figure out the value of x, but I need to move 10 to the other side. The opposite operation of division is multiplication. So if I multiply both sides by 10, that would cancel out 10 on this side, and so x is equal to 4 times 10, which is 40. Now, if I put 40 in there, I'd go 40 over 10, which would equal 4, which is equal to 4, and I know that I've done it right. Let's try another one, a little bit harder. So I could do this in 1 step or 2 steps. I'm going to do it in 2 to help you kind of get the grasp of it, and then maybe I'll do it in 1 step. So I want to get this 5 up to the other side, and I also want the 2 to the other side. I'm going to start by moving the 5 up by the opposite operation, which is multiplication. So I'm going to multiply both sides by 5. That would cancel that out. And it would become 2x is equal to, well, 5 times 8 is going to be 40. And then I need to move the 2 to the other side. The opposite operation is division, so I divide that by 2, and I divide this by 2, and so I go x is equal to 40 divided by 2, which would be 20. So if I put 20 here, and so if in your calculator you go 2/5 in brackets, times 20, you will get the answer of 8, and you know you've done it right. If you want to do this as a 1-step question, you could just start with the 2/5 x is equal to 8, and I would just multiply it by the inverse of the fraction on both sides. So I could simply go 5 over 2, and this is 5 over 2. We'll keep it like that. And then this would also give us 20. All right. We're going to do one more, just a squared to work with. So x squared is equal to 9. The opposite operation of squared is square rooting, so I would square root both sides. And so, of course, the square root of 9 is 3. And if I want to double check that, I could put this 3 back in there and go 3 squared. And of course, that's going to give me 9. And I know I've done this right. So in your homework, you will have varying difficulties, going from very easy to probably a little bit beyond this year's algebra, but definitely stuff that you would do in a Physics 20 class. And it wouldn't be the most difficult. So just keep in mind that this page here is roughly the difficulty of what we're looking at doing. Anything that goes beyond these 2 pages of algebra is more or less just to challenge you if you want a little bit harder of a question to do. But if you're able to do what we did in today's lesson, no problem, then you should be fine with all of the algebra we are going to be doing in physics. Thanks for watching You Got Hope Science. I hope you enjoyed the lesson.